First, you can import a data file, like a CSV file, for instance, using the file import and uploading a file saved on your desktop. Here we are going to analyze the survey data from the sample of UCI students, past students. And we are going to focus in particular on two variables, height in inches and gender. First, let's analyze the categorical variable, gender, with a bar chart. And notice that it gives us the count of students who are male versus female. Whereas with a pie chart, it is going to give us the percent of students who are male versus female. We can get summary statistics using the statistics frequency table and gender. This gives us both the count and the percentage of students in the sample who are male versus female. For the quantitative variable, we might want to plot it with a dot plot, for instance. We plot height in inches for all the students, regardless of gender. And we notice that most of the data are on the right, but we have two really small values that are less than the Guinness World Record of 22 inches. So those are clearly typos. They are not possible values. So we want to exclude them through the filtering option. We want to exclude the rows where the height in inches is less than, say, 20 inches. Clearly impossible values. And you'll notice now that those two rows have been excluded. When we get to the dot plot again with the outliers removed, we now see that we have a realistic range of values, and this corresponds to the large right side lump on the previous dot plot. We do see some irregular distribution here, and we know that male and female adult human beings have slightly different distributions of height. So it makes sense to want to plot and summarize the distribution of height separately for males and for females. A quick and easy tool for that is the box plot, which allows us to do group comparisons at the graph level. So in the Grouped tab, we can select the data height in inches and backgroup gender. We can see now the distribution of heights separately for males and females, and we see, as expected, that even though there is quite a lot of overlap, we see clearly that the distribution for females is lower than the distribution of heights for males. Now, in this case, we have a clear outlier for the smallest male height. However, this is not an impossible height. It may or may not be a typo. So we probably want to leave that in there unless we have further evidence that suggests removing this data point. We may want the summary statistics, same thing separately for male and for female, so using the Grouped tab. And you see the 5-number summary, including the median, that are represented by the box plot. We also get mean and standard deviation. If you want more precision in the numerical values provided, go to the CrunchIt preferences and change the precision. As you can see here, we have now more decimal places offered. If we want to make a histogram, for instance, for just one gender, we'll have to make sure to exclude the other gender. So for example, here, just excluding the male students so that we can show the distribution of female students. And that gives us a distribution, as we had noticed in the box plot, a slightly left-skewed distribution. You can also change the width or the starting points of the bins. They are equivalent histograms, just one is a little bit more summarized than the other one. Both indicate a moderate left skew and no outliers.